First of all, good afternoon, everyone. And I have to thank Mr. Kavita ma'am for this wonderful opportunity. And I'm really sorry for the last week. It's on emergency, so I couldn't give any webinars for the last week. And like today, we are lighting on it. So may I know my audience because I have already created a PPT on transformers of the using NLP. May I know my audience like is anyone working on AI, ML, TS?
No.
No, Vidhyadharan.
Oh, all right. Okay. All right, then is my screen is visible now? My audio is clear?
Yeah.
Yeah.
Go ahead.
Thank you. So before getting started, once again, I have to thank Ruben sir and Kavita ma'am, and very good afternoon for all of the presenters here. So right today, we are going to the topic called NLPs and transformers. So before getting started, let me introduce myself. I'm Vidhyadharan, working as an associate and R&D at VA Labs Research and Development Solutions, and I'm a C# owner MVP. All right, then. So is this Learnathon is about transformers that we seen in science fiction movies? I think the answer is really no, because the session is not about Optimus Prime here, and we may wonder like is the transformers any kind of an electrical device? So when it comes to electronics and electrical department, the answer is yes. But when it comes to our domain like data science, machine learning, artificial intelligence, natural language processing, deep learning, it's a different story. So the next point is like, welcome to Transformers, the NLP revolution. So first thing first, so we have to understand that the NLP is a subset of an AI. So that will enable the machines to learn and manipulate the human language. Like the human language represents like you can make some text to audio or audio to text, some kind of stuff. And proceeding with that, we have to know that the transformer is a deep learning model that evaluates the input and output data representations. And where is it being used? You may ask, okay, Vidya, so where is the transformers and NLPs being majorly used? So the major thing is like transformers are being used in every industry of computer visions, as well as in the natural language processing. For examples like Tesla cars that is running on automations, is using the transformers and the computer vision and natural language processing models. So by the end of the session, if you guys have any queries, you can ask me and I will clarify that. So let's keep in proceeding. So what's the use of transformers? The next thing. So we guys are using Google Translate nowadays. Transformers can be used to translate the text from one language to another. And in addition with that, we are going to see a demo of a Twitter sentiment analysis because text classification and that kind of stuff. So the transform is also being used in the sentiment or emotion behind the piece of text. That is like Twitter sentiment analysis, and it can be used to generate a human-like text on given input. Like we have been using ChatGPT and Google Bot, that kind of stuff. So when we give some kind of an input query and we can get the output right, even though the ChatGPT 4th version can write the codings for it. And another thing is like compared to Transformers, the previous version of Transformers, like some of me have heard the term about recurrent neural networks. Simply, we can put it as an RNN. So it has some kind of a limitations of processing the inputs. But when it comes to Transformers, it has an ability to process the input of any length, so that handling from text to entire articles. So why do we use the Transformers in NLP? Because it has an improved performance when compared to recurrent neural networks and like long-term, short-term memories, and it has a better efficiency compared with RNN, and it is easy to implement. So the next thing is people, let me put it straight, because I'm not very good at writing phrases of Okay, I'm just putting the simple sentences which I've been mastering on this all day. And this is my, I think it's been 2 to 3 years since I have given a webinar. So please don't take me wrong. If you guys have any queries, please let me know in the end session of this. Okay, fine. So let's get started. Let's continue. So we are seeing the basic overall view of an architecture of a transformer. So before seeing a deep dive into this, that the term transformer was coined in the year of 2017, and the research paper called "Attention is All You Need." So what is the transformers all about? So we have seen like the transformer is able to use in the Google Translate, or else we can be used to use in the computer visions and natural language processing. The all you have to do is like you can just give the inputs inside this. All you have to give the input inside, and the following input will travel to the multi-head attention and the feed-forward layers. So proceeding with that from one layer to another, it will pass through the output layer. So from the input layer to output layer, it will transfer from the mask to multi-head attention, and it travel from the one layer from a multi-head attention to another one, and keeps on proceeding with that. And it's after passing through several layers of decoders, we can be able to obtain the output. The input is called encoder, and when it comes, the output is called a decoder. Let's take another example. This is an overall architecture of a transformer. So this is a basic architecture of a transformer. So when you give an input, it will pass through the encoder. So for example, let's take and translate text like, hi, how are you? So when it thinks, when they hi, how are you, the text that's been given as an input, it will travel to the encoder. Likewise, and after it's simulating, after traveling through the feed-forward neural network and attention, self-attention in layers, it will transfer to the decoder port. So when it comes to decoder port, it will again decode about the feed-forward network and encode and decode attention and self-attention layers. So proceeding with that, we can get the so likewise, it's like the same part which is going through in the previous slides, because we can be able to understand in an easy manner. That's what I think. So as like it said, the encoder mechanism is all about inputs, and the decoder mechanism is all about outputs. So when you pass the inputs, when you pass the some kind of a text to the input, it will pass through the every layers of the input, and it will transfer to the output sessions. So after that, it will transfer to the every layers of it, and proceeding with that, it will travel to another layer of the feed forward and linear softness layers, and we can get the outputs. Similarly, we know that every machine couldn't understand what we are going giving an input like, hi, how are you? This is an example that every human can be able, every human can understand, because we communicate with each other. But when it comes to machines, and we have when it comes to human and machine communications, machine couldn't understand like, hey man, what is this sentence? So how does it look? So every machine will process the input in the form of matrices and in form of vectors. In a simple term, we can put it as in numbers, right? So that's what he's going to on, and I will explain about in the upcoming slides. So what's the key of success in transformers? So this is an important part when it comes to transformers part, transformers topic. So I have to put this point because the self-attention and attention mechanism. There's two types of mechanism. This two type of mechanism is the important key factor success in these transformers. Because why? Because when compared it to transformers, the RNN couldn't do every fact. The RNN is not a successful transformers, because the transform is the successor of RNN. I will explain just a minute. So what I said is like that attention and the self-attention are the basic mechanism which is a successor of transformers. So what I'm trying to say is, when you guys are giving some kind of input and you guys are waiting for some kind of an output. So we can able to obtain the output. So when it comes to making of predictions, the attention and the self-attention mechanism is both involved in transformers to attend the different parts. So in simple words, we can say that the transformer model is uh, we can in a simple words we can say that in making the predictions, the transformer model will able to give attention what to the different parts of another sequence. In another words, we can say like this is an RNN. It's a previous form of a successor. It's a former of a transformer because what can I say is like when you guys able to give us some kind of a input like this is a dog, so how does the RNN will encode it and decode it? So one word at a time. It will take just one word at a time. It will pass through the input. The encoder will also process to like the encoder will process the input into vectors and matrices forms. So this is an limitations of RNN. So when it comes to transformers, we can be able to give multiple number of inputs at the same time. So we can see a single input is being given here, but when it comes to here, we can see the multiple number of ports is being given as an input, right? So the transformer accepts both the D, the red, the dog word as an input. It will use the encoder format to encode the text, and it will be able to process to it. And we can be see the multiple number of vectors, matrices, and calculations can be done within the use of transformers. So consider this is an we can be able to see. Um, so we can be able to see that this is an English, right? The input is given in English. Consider the same sentence just given in some kind of an German or French. It may involve some kind of words, right? So we can use the Google Translator for this. So when you give an input in the form of French words, the transformer encoder will accept the input. It will process through the some kind of a encoding that we have seen in the feed forward, multi-head attention, that kind of stuff. It goes through it and it generates a vector and matrices stuff. And after that, we can be able to pass it to the decoder. So finally, after passing through the several layers of a decoder, we can be able to achieve the some kind of an output called the red dot. Can you guys follow what I'm trying to say?
Yes.
Yes, Vidya, continue.
Yeah, thank you very much. So this is the basic point behind the transformers. So before that, on the next hand, we can say that the self-attention mechanism. We have seen about the attention mechanism, and what about the self-attention? So on the other hand, the self-attention refers the ability of transformer model to attend the different parts of input sequence while making the predictions. Like we can say just a minute. So let's take an example of this. See, we have a sentence called I poured water from a bottle into a cup until it was full. So it refers to it, the word H. We can make it. We can take this word. So the it word references the cup because it represents an object called cup. So what I'm trying to say, I poured the water into I poured the water from the bottle into the cup until it was empty because the it refers to bottle also. So what I'm trying to say is, when it comes to RNN, if you pass this sentence into RNN, it will take the each word at a time. It will pass to I, and it will take word, and after that it will take water. Proceeding with that other words, it will take all of them. But it has some kind of memory limitations. So uh, it was a drawback of the RNN. But when it comes to transformers, the I poured the water from the bottle into the cup until it was full. It was an entire phrase, right? It will take the input into with the help of transformers. It can be able to take the entire input into the one sentence, and it can match. All right, this is an input this is given by the user. So what is trying to ask, it will rearrange the words. How does it rearrange? With the help of encoders and decoders, it can be able to imagine itself. So after coming to the next point, we are going to see a demo called Hugging Face. In that, we can be able to use the pipeline library. So with the help of pipeline library and pipeline functions, we can be able to see an output. So the concept behind this, yeah, the concept behind this, the rearranging of words involves the pipeline function also. Can you guys follow me? If you guys have any doubt, please let me know. People?
Please proceed with the other.
Please proceed, Vidya.
Yeah. Thank you. So following with the next step, we can see the what's in self-attention mechanism. So the self-attention mechanism is sometimes called as an intra-attention. So the intra-attention mechanism is like when you process a single sequence of input, we can be able to process the another sequence of input at the same time, so that we can be able to get an output in the output for the same sentence. So by changing the one word full to empty, we can be able to get the object. So with the help of object called it, the entire sentence can be renamed into, or it can be rearranged into whatever the meaning is meaningful. So by using the pipeline functions with the help of encoders and decoders, it is possible to implement. So everything has some kind of limitations, right? What I'm trying to say is that the transformer is the successor of RNN. What I'm trying to say is RNN is the base for transformers. Like RNN has some kind of limitations, like the memory limitations, and it couldn't process some of the words at the same time. And what can I say is like it requires a more number of data to get trained. That kind of stuff is also limitations of RNN. But when it comes to transformers, it beats success of RNN, but it also some kind of limitations. One of the weaknesses is like it is hard to control in this attention. And another thing is like it requires large amount of memory. The same limitations of RNN is being also faced in the transformers of limitations, guys. So the next thing is we are going to see a demo. And before that, let's see what's mean by a Hugging Face and what's being used for. Well, people, we can say that the Hugging Face is an American company. They provide they are open source data community, data source community peoples. They are providing some kind of web APIs for using NLP, NLP sortouts and some kind of things. They have been providing us. So why should we move to pre-trained models like Hugging Face? We can say everything building from the scratch is a little bit tough, right? We can say like when you are trying to build a model from the scratch, it requires much more amount of time, and it will be a little bit difficult. The same thing is going to I'm going to say, because when you are trying to build architectural models like BERT and some kind of another architectural models like whatever the model we have been working on, it's very complicated to build from the scratch, because we have to use a more number of data and a more number of NLP sort of things. So that's why it's a good practice for beginners to use the pre-trained models such as Hugging Face library. So let's get an example of a Hugging Face. So the Hugging Face, which I've been mentioning, is like they are a AI community. Um, they provide a web API tools to every person that is who are looking for to learn transformers, that kind of stuff. They have been providing the API for them. So for this, we are going to use Google Colab, because I have already mentioned, I have already made a demo for you people. So let's get started. So the demo has been split into two parts. Like one, we are going to use the models which is available in the Hugging Face alone, and we are going to use the same NLP sentiment analysis using our own text, some kind of we can use. So for using the Hugging Face libraries and that kind of stuff, we need to use we have to install libraries called transformers. So for that, for installing the library called transformers, you just need to write a command like pip install transformers, and you just can execute by executing this play button or run button.
Vidya,
Google.
sorry to interrupt you. Are you showing us the Hugging Face page or
No.
no?
This is the Hugging Face because this is a website that is coming that is
We
created
are
by.
seeing only your PowerPoint presentation slide. We are not seeing anything else. Maybe you
Oh,
need to
sorry,
share a
sorry,
different.
sorry. I'm sorry. I didn't notice that. Sorry, people. Right now, is it visible?
Yes.
Yeah, sure. Okay, sorry guys. Let me bring this again. Like I said, Hugging Face, they are an AI community. They provide web APIs for training, building, and making models, kind of. So for right now, we are going to divide the demo into two parts. Like we are going to use the pre-available models for processing, and we are just going to make a sentiment analysis within 5 lines of code. This is just a demo part, so we are going to do in the 5 lines of code itself. So for using the Hugging Face library, we just need to install in one library called its transformers. So the transformer is an available, it's a library that is being developed by Google, and it's being used in PyTorch, TensorFlow, and Hugging Face. You can be able to use this library in any kind of stuff. So for that, all you have to do is use this command called pip install transformers. So when you guys use the Google Colab, it's already available in the Colab server itself. So it will pull the resources, whatever the resources need. So after executing this command, it will install all the packages. Like if you Google Colab is completely free to use. If you people need higher GPU levels, then you have to go for proprietary. So this is a basic one. So I'm just using it for free purposes. So after installing this library, we can be. I've already made an output for this. So please people don't get any sort of it. So we can see the requirement has been already satisfied. And the next thing is like, what we are going to do is we are going to use a function called a pipeline function from the transformers library. So for that, what we are going to do is we are going to import the pipeline function. So for that, we are using the from transformers import pipeline, and we are just going to declare a variable, and we can assign the pipeline function with some kind of an arguments in it. So let's say it's called sentiment analysis. So when it comes to Hugging Face, they provide all the models, like whatever the models you need. So they're providing the model in multimodal, they are providing the model in computer vision, and they are providing the models in natural language processing, and audio, tabular, reinforcement learning. Yeah, they are providing all of the models. So what is the thing you need? You have to be very specifying that. For example, in this section, we are using about text classification. So for that, we can be able to select the text classification from the natural language processing of Hugging Face data. So they provide data sets, they provide predefined models, they provide docs, solution pricing, that kind of stuff is entirely different. So let's take the models alone writers. So you people just need to create an account in a Hugging Face. It's totally free to use the predefined models. And after creating your accounts, you just need to use the text classification or computer visions or face extraction, whatever stuff you need. we can use. So when it comes to today output, demo, we are using for text classification. So for example, this is an sorry, people. So we are going to analyze for a text sentiment analysis, right? So for that, let's declare another variable into a list, and I say I love you and I hate you. These are the two type of sentiment analysis text that I have been working on. So after calling this function, it will download the some kind of libraries which is available in there. So after importing some kind of modules, instances, it will give you an output. So saying that just a minute, people. So can be able to get an output. So we can be see we can be able to see that the label name called positive. The sentiment which has been given here is based on positive mindset. Its score is 0.998, which is equal to 99% of which is equal to 99%. The text is very good. So when it comes to another sentence, like it's an I hate you, the label showing that it's a negative word and its score is 99%. So what does the score here indicates? The score in here indicates that the sentence which has been paused here has the sentiment of positive or negative. For example, the sentence "I love you" as a positive word, and it has the accuracy of 99%. That is, it is positive sentence. So when it comes to here, I hate you, it shows that the score value is 99%. It's a negative sentence. So that's what it's going to represent here. So when you are going to use sentiment analysis. All right, Darren. Let's leave it apart. And this is an user-defined one. So when it comes to mind, there's a question that comes in your mind. So how about the models, man? So here comes things. So we are using the Hugging Face. We have been selected the models, and we have been selected text classification, and we can be able to see 19,941 models that has been previously here, which is pre-trained models that is available in Hugging Face. For example, we can select any one of your models, like all right, Robert Base OpenAI director. We can be see guys, it has a message like I like you and I love you. Sure, okay, fine. So what we're going to do is it model. So what we are going to do is we are going to use this pre-trained model file to see whether the sentence, whether the data holding up in this model is positive or negative. That's what we are going to check it. So for that, I have already made an code. So what is it? So what is you have to do is you just need to declare a variable, and you just need to call again the pipeline function. Instead of instead of the arguments, we just need to give the model name. For example, the model name which I have been using is Roberto Base OpenAI Director. Just copy the model name here, and it guys just paste it here. And all you have to do is just to run the project. So it will download the entire downloading instances, and whatever stuff it requires, it will download, and it will train, and it will build. Maybe we can get the output. So we can be see it's a label is a fake. It's 99%. What is the fake? It's a negative, man. So it doesn't seem like the data is fake. It says like I like you, I love you, that kind of stuff. What we don't need to bother what kind of data that is it's holding on. But when it comes to training, building, and execution of the product, we have to deal with what kind of output is you are expecting. So can be expecting like it shows that 88%, it's a fake one. But when it comes to Colab, it shows that the fake score is 19%. So what's the difference? The same difference is again, everybody anyone can achieve the accuracy of 90%. If you want to get the accurate percentage, you have to push the you guys need to do some kind of things like parameter tuning, that kind of stuff. The parameter tuning is an optional one, but if you need to achieve the accuracy level, then you have to proceed with the parameter tuning. So after proceeding with the parameter tuning, we can be able to achieve up to 95%, but it's showing the 99%. 95% of accuracy score is a very good one. So this is a part of one demo. Are you guys following this? Can you guys able to understand?
Yes, Vidya, proceed.
Yeah, fine. So here comes the major part. It's not a major part, it's a really short time, because what we are going to do is we are just going to make a sentiment analysis within the 5 lines of code. So for that, we are going to do the same procedures what we are going to do. So first of all, we have to install the transformers library. So the requirement has been already satisfied. And the next thing is I have imported the pipeline library. And let's use the pipeline sentiment analysis again. So for that, you just need to use the pipeline function. Inside of the arguments, you just need to pass the sentiment analysis. And after that, let's name a given name. Hi, hope you are doing well. So let's make this part with. So we have given a sentence. All right, sorry. Since the installation of transformer libraries has been done, we haven't run this code. So it's showing some kind of an errors. So let's look in this one. So it's showing that the text or whatever the stuff we have written inside the parameters, it shows a positive sentiment, and the score is 19% accurate. So the next coming to the next point is like let's just give another example like so the session is going to over. Oh man, this is a negative one, right? So let's run it and let's see what is the negative, what's the label score. So we can see that the label score we have got is negative and the score value is 19% accurate. It's a negative one, man. So that's it. It's a simple example. You guys can understand, I think so. So if you guys have any doubt, please ask me.